Last time we touched this was a while ago. There's no timestamp on here, but it's been a week. It's been a week, so I'm a little rusty. Let's get back into the swing of things here. And we're going to work on Advent of Code 2022, Day 24. Day 24, Blizzard Basin. With everything replanted for next year, and with elephants and monkeys to tend the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat open area that serves as the extraction point. It's a bit of a climb, but nothing the expedition can't handle. At least that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. As the expedition reaches a valley that must be traversed to reach the extraction site, you find that strong turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes. To make it across safely, you'll need to find a way to avoid them. All right. Fortunately, it's easy to see all of this from the entrance to the valley. So you make a map of the valley and the blizzards, your puzzle input, for example, this. The walls of the valley are drawn as hash. Everything else is ground. Clear ground, where there is currently no blizzard, is drawn as a dot. Otherwise, blizzards is drawn with an arrow indicating the direction of motion, up, down, left, or right. The above map includes two blizzards, one moving right and one moving down. In 1 minute, each blizzard moves one position in the direction it's pointing. Okay, I see that. Due to conservation of blizzard energy, as a blizzard reaches the wall of the valley, a new blizzard forms on the opposite side of the valley, moving in the same direction. Oh, okay, so they're saying this wraps around to the top here. Okay. Because blizzards are made of tiny snowflakes, they pass right through each other. Okay. After another minute, both blizzards temporarily occupy the same position, marked 2. After another minute, the situation resolves itself, giving each blizzard back its personal space. Finally, after yet another minute, the rightward-facing blizzard on the right is replaced with a new one on the left, facing the same direction. And this is our starting... Oh, that's not our starting condition. Yeah, it is. Okay, this is our starting condition. And so we just loop around. So this just makes loops of blizzards. Okay. This process repeats at least as long as you're observing it, but probably forever. Here's a more complex example. Your expedition begins in the only non-wall position in the top row. That's up here, right? And needs to reach the only non-wall position in the bottom row. That's down here. Okay. I think I got it. On each minute, you can move up, down, left, or right, or you can wait in place. You and the blizzards act simultaneously, and you cannot share a position with the blizzard. In the above example, the fastest way to reach your goal requires 18 steps. Okay, and then they just go through this, and this will be our test, right? What's the fewest number of minutes required to avoid the blizzards and reach the goal? All right, so let's grab this as our test input. Copy, okay, test input. Paste. And let's get our real input. Oh, shoot. Okay. I guess my my thing expired, which means I have to get... Okay, we'll get it the old-fashioned way. We'll put this back where it was, and we'll just get the input the old-fashioned way. Oh, I am logged out. Okay, so I do need to log in. Let's do that over here. Log in. Click, click. I'm now logged in, and I'm not going to go through the whole session key thing. I will do this. 24. Go to the end. Oops. No, I don't want to switch screens. Go to the end. There we go. Get my puzzle input. Oh, that's not too bad. Okay. Cat input 2022-24.txt. Right, that file should be there. Okay. Okay. Very good. And then maybe after I'm done with this, I'll figure out the whole session key thing again. So what size is this? Let's take a look. It is 22 by 152, which means it's 20 by 150, right? Because it looks like we have, I mean, the blizzard section of it. right? Because we have one on the front and the back, and one on the top, one row on the top and the bottom, one column on the left and the right. And so the actual blizzard itself is going to be, it's 22 by 152. 20 by 150. Okay. But our test is smaller. It looks like it's 6 by 4. All right. Let's start by going into the file that contains all of our calls. And we'll create a new one of these guys, new one of those guys. Gotta replace those with 4s. Day 24. And then over here we'll just run Bacon. And there we go. That took a little longer than I thought it would. Okay, so parsing should be, let's see, we're just going to ignore the walls, or should we use the walls? Let's look at this one here as we're coding this up. We can use the walls as barriers. We can detect, well, let's see, how are we going to store it, right? Because these things can pass through each other. And I think it would be painful if we stored each location as a vector of possibilities. Maybe we could just use a bit mask. So even before we start the parsing, let's create if we have a blizzard that contains, let's say, a width, yeah, it's always tricky using U sizes because of the having to deal with up, down, left, right, and subtracting and adding and stuff like that. What we can do is we can store the whole thing as just a vector and then just write little translation routine. We can make the map just a vec of U8s. And then inside impl blizzard, we can have the different types of blizzards, right? Const up U8 is equal to x01, for example. And we'll do up, down, left, right, and wall. And this will be 1, 2, 4, 8. And let's just make the wall the high bit. So to create a new blizzard, we'll just need a width and a height. Return self, and it's a self of width, height, and map is a vec bang of empty, I guess, width times height. That should build, although we'll get warnings we're not using them. It doesn't build because expected U size, right? This is going to be the tricky part, is translating back and forth between the U sizes and the I64s. Didn't like that. Oh, because I didn't put the as U size part. I put the brackets around it, but I forgot the rest of it. Okay. So as we parse through, we can just look at the different characters. Let lines is equal to lib read lines of test input text. Let width equals lines 0 dot len as I32. Let height is equal to lines len as I32. And then let, oh, and then this is going to be the blizzard. What kind of terminology should we use here? Is a field? Was it a valley? Valley. Is a blizzard. Okay, so then we can just say, oh, and then we have to derive default. Oh, we did. Yeah, so let's just do self blizzard equals blizzard new. It's hard to type. Width and height. And then I'll create a little draw function so we can print it out. For row in 0 dot dot self height, or call in 0 dot dot self width. I guess what we can do is just check for each one of these conditions and then just draw. Do we need to draw the number, or can we just? I'm going to just draw capital X where they merge. I think that'd be easier. We can just say match self of self get row call fn get self row I64. Oh, I'm doing I32, so I32 call I32, and it returns a U8, and then we just say self dot map of row times self width plus call as you saw this. All right, so if it's self up, then we're going to print, oh, I can just put this in a print, bang, this, like that. If it's up, we can just say, we'll do the up character, self down is a down character, which is V, self left is left, self right is right, and then wall, right? And then that's, as I was saying, I think for the multiples, which means it's going to be a combination of some of these, I'm just going to put a capital X for now. We could always count if we want to. Close the print, semicolon, close the for, println, and that. Okay, so now that's the draw function. Let's draw it. Self blizzard, typoed that one, draw. All right, let's see what this looks like. And I misspelled it up here. Oh, I called it the valley, right? And we messed up. Oh, because I didn't set anything. They're all zeros. Oh, right. 0 is going to be a space, right? If it's 0, we just draw a dot. So I think since they're all zeros, we should just get zeros. Didn't like that because I did the wrong thing here. All right. All right. So now we can parse. For line in lines, yeah, for character in line.chars, match C. If it's a hash, then we're going to say, oh, can we just do it with an index directly into the thing? Let mut idx equals 0. and then just increment IDX each time. Self valley dot map of index is equal to self wall. Now I guess there's no merged ones here because it can't be, because we wouldn't know which way they were going. So I'm going to assume there's no merged ones in the test input also. I mean the actual input. So we can do it for all 4 directions. Right, up, down, left, and right. Down, left, right. We also have a space, which means do nothing. And then everything else we panic because we don't know what to do with it. Panic, unknown, char, C. Like that. And then we increment IDX. And do that. And now we should be able to draw out the map. Let's see what I messed up. Oh, not self wall, right? There we go. Blizzard. So it should look like this. Yeah, I think that's it. I think we got it. Okay. So I think the next step for part 1 would be to try to come up with a way of moving all of the blizzards. The blizzards, you and the blizzards act simultaneously. So I think the right way to do this is to, we start here, right, where it says E. We move all the blizzards, and then see can we move at that point. I guess one option would be is like if we're in the middle of the thing and a blizzard moves on top of us, we can't do the no move thing, right? Because that's one of the options. So you kind of either move up, down, left, or right, or you can wait in place. So in that instance, like here, you have to move. Right, because this blizzard is about to move on top of us, so we don't have a choice. We have to move, whether it's left or down or up or right, doesn't matter, as long as that next space is empty. And the only way to know if the next space is empty is to actually move all the blizzards. So I think we have to create a new blizzard map from the current map and say, okay, here's the new state, and then we're going to need to know where the player is. All right, can we at least do this? Let's see if we can get from this state to this state. And again, I'm drawing X's instead of how many are there, but we can always change it to how many are there if we need to, just by using count ones. We also have to figure out how to do wrapping. So Fn, call it tick, for 1 tick of the clock, which returns a brand new self. So we go through each one of these things and then look up, down, left, and right to see what blizzard is going to come to that new location, right? So we're going to start a new map. I might not have to specify it's a U8. We can loop over each entry in the map and then look up, down, left, right. And then we have to deal with the cases where we wrap, right? So, for example, this location gets this right moving, and we can see that here. This right moving blizzard wraps around to here. So should I do a row call for row in self 0 dot dot self height, or call in 0 dot dot self width? And we can look up, down, and left and right for each one of the blizzards. We can look up for a down blizzard. We can look left for a right moving blizzard, right? Because if we're here, we look up for blizzards coming to us. We look right for blizzards coming to us. We look down for blizzards coming to us, or we look left for blizzard that's coming to us. So can we do that with a little help from a const? Look. And this can be, let's see, the type has to be some vector. So we're going to look up. So up is -1 on the row, 0 on the call, and we're going to use self coming down. Okay, I think this is the way I'm gonna do it. We'll have all these tuples in here which show us what we're doing. We're gonna look down for a blizzard that's coming up. We're gonna look left for a blizzard that's coming right, and we're gonna look right for a blizzard that's coming left. But we also need to deal with the wraparound case. And so this is a I32, I32, U8. Do something. Let's see if that, is that type check? Comma, U8. Oh, this has to be of 4. There we go. Okay. Now it type checks. All right. And we also need to deal with the wraparound cases. If we look up and we see a wall, that means we have to look all the way down. Should we put that also in here? How do we do that? Let's see if we can figure it out as we go through. Match self get row call. All right, just like we did with the draw. If we're on a wall, we just want to transfer the wall over, right? I think we can do this with the IDX, just like we did the other one. Then map IDX is equal to get row call. This is just basically busy work, unfortunately. There's no real thinking involved here. It's just making sure you handle all the corner cases. Self wall means map IDX equals tile. If it's 0, if it's anything else, so we can just say if tile is equal to self wall, and map IDX is that. We don't need to do a match statement. Else, we're going to loop over all the looks. And then the tricky part is the wraparound. For L in look. And this should just be that. Okay. Let pause is equal to look row. Let's call it look row is equal to row plus L dot 0. Let look column is equal to col plus L dot 1. If, oh no, it's L dot 0 dot 0, L dot 0 dot 1, right? That's okay. I think it's right, but even though it's showing the wrong type, if we want to look up, self get look row look col and L dot 1 is not equal to 0. That means we found the tile, right? We just anded the down, or the one up from us with the down. And if there's a down one coming, then we want to say map idx or equals self, yeah, L dot 1, basically. You probably can simplify it. I say map idx or equals, wow, that. Okay. And then we still need to handle the wrapping conditions. Let tile equals this, right? And then we're going to check again. If tile is equal to wall, handle wrapping. And we'll figure that out in a second. Else this. Oh, no, that was almost right. Tile. Like that. Like that. And like that. Okay. If it's a tile, then we have to handle wrapping. How do we handle wrapping? We need to know which direction we're looking so we can look in the opposite direction. Is there something we can do with width and height here that'll allow us to, like somehow we need to change -1 to be column 1, and we need to change a +1 to be column width -1, -2. I guess we'll just do it this way. Oops. Match. And it's just going to be L0. Okay, yeah. Match lock. So this is looking up. We're going to look all the way down. So it'll be self height -2, comma. Oh. This is bad. Self height -2 and then from .1. If we're looking down, then we want to look at row 1 from .1. If we're looking left, then we want to look all the way right, which is from .0, comma self width -2. And otherwise we look, if we're looking right, we want to wrap around all the way to left from .0, 1. All right. So the map IDX is equal to, or equals, self get. Oh. Let L row, L col, can I do it that way? Is equal to self wrap from, which is our current location, row col, and our offset, which is L.0. Yeah, and then we can just say self get L row, L col, and OX. No, and L1. Wow. That's complicated. And then we have to return a new self. Width is self width. Height is self height. And a map. Oh, I didn't handle all the other locations. Panic. Bad location. Lock. This should be look. Let's call it look. Right? Can't do that? Oh, okay. Fair enough. Smab, hello. Sorry, I missed you earlier. Okay, we're not using look. Oh, because I'm not calling tick yet. Okay, so it builds. Let's do this in part 1. Is we can say let new valley is equal to self valley dot tick and new valley draw. Let's see what happens. And it panicked. Len is 0, but the index is 0. Really? Oh, because I'm doing it this way. Yeah, I shouldn't do it this way. I can just push it, right? Map dot push tile. Oh, I can't yet. Can I? I have to do it this way. Map dot push 0. Self. No, let not IDX equals 0. And then, now that I'm thinking about this, I forgot to increment index. Okay, let's see what that does. Still not good. Len is 48, but the index is something negative. And that's on line 86. It shouldn't ever go negative because the wall should stop us from looking up, right? If we're on a wall, then we should just do this. Smab says, this is one of those hated best path days. I didn't take beyond modeling the problem this year. Ah, okay. Fair enough. I'm just trying to see if I can actually just get, I mean, it seems like a simple function to just get the tick function to work, right? But I'm already having problems. Right, the len is 48, but the index is some negative number. And I don't know why we would be going negative. Because, okay, let me do an assert here. Row is greater than 1 and row is less than self height minus 1. I'm assuming it's the row, but it could be the col. Let's do that in the col also. And this is width. Oh, well, it is the row. Okay, I should actually print it out, right? Zero, 1. Oh, duh, right, because the 0, 1 is a blank. Ah. Okay, so we could just check it here. If row is less than 2 or row is greater than self height minus 2 or col is less than 2 or col is greater than self width minus 2, then we're going to just do this. Here we go. Okay. Did we even come close to the next step? We did not. Actually, we came pretty close. We're missing this one here. And this should be empty because the E got on there. And there should be 3 here, so that should be an X. So I'm close. Smab says, are you mapping the wall or the inside areas? I'm trying to just map. I'm mapping the whole thing. I'm making a brand new map from the old map. Just to see if I can do that one step. And I'm close, right? You see the X's here. This is wrong. Oh, so it looks like... Oh, okay. Maybe it shouldn't be less than 2. Maybe it should be... Yeah, less than 2, right? So 1 or 0. Oh, no. No, that's wrong. If row is equal to 0, col is equal to 0. Let's try that. And that panics. 1, 1. Oh. Yeah. Whoops. W. That was weird. Okay. I think this is it. Yeah. Let's do 2 ticks now. Right? Let Mount Valley is Self Valley clone. And then what we'll do is for in 0.2 new valley equals new valley dot tick. And then we'll draw it. So then hopefully it'll be, oops. Oh, we don't have clone, right? All right, 2x2. I think we have it, right? Let's do 18. Let's do 17 since that lines up. Okay, so it managed to successfully get through 17 minutes. So I think we can declare that part of it done. Now we just need to Dijkstra our way through it. And the only reason I suggest Dijkstra is because we have a Dijkstra implementation as part of our library here. So yeah, let's do that. Use AOC lib. We've got to look up what it's called though. Dijkstra search. And I just have to implement moves and whether or not we're in a win state. How hard could that be? So impl Dijkstra search for Blizzard. Fn moves self, and it can return a vec of self. Let moves equals vec new. So the first thing we'll do is we will tick time forward once. Let new state is equal to. Oh, we have to keep track of where the player is. Smab says, don't forget there are 5 possible moves each tick. Right. We can possibly move up, down, left, right, or not move at all. Thank you. Dante Celis, hello. Right. In order to know if we are winning, we need to be able to tell whether or not we're at the end. Right. So we do need to add the player position to the Blizzard here. Player pause. And now should I store this as a tuple or should I store it as an index into the map? Let's do tuple for now and then we'll see. Player pause starts at row 0, column 1. And we'll see if that makes a lot of pain. Oh, and then when we do the tick, we also have to update the player position. Oh, yeah, but the player position might be invalid at that point. We'll just copy it over. Right, if a blizzard moves on top of us, then that's not a valid state. So we just have to be aware of that. Let new state is equal to self tick. All right, so now we can look down, up, down, left, and right to determine if we're allowed to go there in the new state. And what we'll do is we'll clone a new state. Oh, I know what we can do. We can say in here, we can create a function that says move to self we'll call it player move, and then we'll just give it a delta of I32, I32, and this will return an option self to say whether or not it's allowed to. Oh, but that's annoying. Okay, I don't want to do that then. I want to do bool. And all we need to do is say self get delta 0, delta 1 equals 0. Valid move. All right, so we have the new state and we have the player's position. Let's do this. Move up is equal to player pause dot 0 minus 1 self player pause dot 1. Right, let's move up. And we have down, left, and right. And these should always be, oh, I was going to say these should always be valid because we're never going to move off, but we have to check for the start and end locations. All right, I'll do that in a second. So move down is +1 here. And then left is -1, and then right is +1. So we can actually check that. Well, let's get rid of this. I'm not going to use it. I'm going to just put it in right in here. For new pause in, move up, move down, move left, move right. If move up is greater than or equal to 0, oh, sorry, new pause dot 0 is greater than or equal to 0, and new pause dot 0 is less than or equal to less than self height. Then we'll check to see if it's a valid position. If new state dot get new pause 0 comma new pause dot 1 is equal to a free spot. We'll say moves dot push. Oh, we'll say let mut valid is equal to new state clone. Valid dot player pause is equal to new pause, and push valid. Okay. We also want to do the no move. So let's add that. Stay. I almost forgot. But then thinking about chat reminded me of SMAB, and then SMAB reminded me. Oh yeah, and then it said and stay put. I like that. Stay put. Okay. I think that's it. Then we just return the moves. And then we just have to check the end state. Is FN is win state. Yeah, so we should still be able to go to the end location if we need to. And the win state is simply if, we don't need an if, we can just say self player pause is equal to self height -1, comma, self width -2. Let's see if that builds. It gave us no warnings, which is weird because you'd think that implementing this thing and not using it would say this is dead code, but I guess Rust can't tell. All right, let's go back to the top here. And instead of stepping 17 times, we're going to call Dijkstra search, this function here. Right? So all we need to do down here is say, and this is where everything fails for me, usually. We're going to get an end state and a count, and that's all we care about is the fewest number of minutes required to avoid the blizzard and reach the goal. So we only care about this guy. So we should be able to say self valley. Oh, DIJKSTRA search self valley, reference self valley. That's it, and then .1. Because we don't care about the end state, we only care about the number of steps. Okay. And I'm going to not run this in Bacon, because if I just ended up with an infinite loop, then I have a problem. Oh, EQ. I wonder if we can derive that. I am the briefcase. Thank you for the follow. All right, I'm going to quit out of Bacon. And then I have to derive partial EQ and EQ, right? Those should all be derivable. And I'm still missing hash. Hash should be derivable. We don't have any funky things in here. Oh, I have to unwrap first. Okay, let's see what happens. Bacon, oh, cargo run. $18. Okay. Should we try with the real input? I mean, seems like we got something here. 2022, 24. The only thing is I bet you the real input's going to take a lot longer. Let me try running it in release mode. Oh, yeah, and I should take out the draw function. It is taking a while. I imagine there's plenty of paths. What can we do to speed this up? Well, one thing we could do is, I mean, as we recognize from the beginning, right? The first example, it repeats after a certain number of cycles, and it's probably whatever the lowest common multiple is between the width and the height. And we saw the width and the height was what was 20 by 150. So I bet you there's only 300 states. Is there a way we can rework this so we just keep track of 300 states here? And then just look them up each time instead of having to calculate them. Because that's what I'm guessing is taking the most amount of time is this tick function. So we could just pre-calculate them all. And then we have to know which tick we're on. Yeah, the only problem is I don't want to have to copy everything. We'd want to have this as like an RC to a map. Right, we could store the maps. We could store all 300 maps in here, and then just index them. It's a vec of U8s. And then in parse, what we can do is after we've gotten the maps, we can just run the tick function on each one and save it in the map list. Can we do that here by doing an RC? That's the question, without messing up my code too much. This would have to become a U size to index into, right, into map list would be a reference count to AOC 2022-24. Right, and then we could use that index to do all the mapping. Or, yeah, maybe that's a dumb way to do it. Maybe the right way to do it is not put the player pause here, but create all the maps here. And then create, yeah, it's the map list. And then create a struct state, which contains the player pause and the current map that the player is on. Which U size? Wow. So that took over 4 minutes. It came up with a number. Let's see if the number's right. That's the right answer. Okay, that's good. Then what I'm going to do is I'm going to commit what I've got. Oh, right. Git add input, git commit -m 2022 day 24 input. Oh shoot, collapsible if. No verify. Okay, so I'm going to undo all these changes to get back to where I was before I saved. Ooh, I went too far. Yep. Self Valley. And there was the unwrap also. And then removal of the draw. That was dumb. Okay. Yeah, okay, here we are. But now I need to fix that Clippy problem. Akuma Matata says, hi, I think we can go faster by pre-computing the positions of the blizzards because they're the same for every tick. Yeah, so that's what I was in the middle of starting to do. And then I got interrupted by the fact that we came up with the right answer. So let's get this checked in. Committed rather, and then we can, oh yeah, so and this, that's all it's saying. That's uglier, isn't it? Oh no, yeah, yeah, that's right, that's correct. It's just annoyingly annoying. What I can do instead, maybe saying, I was thinking, well, I could just put a filter on it, but that's going to be just as annoying. All right. All right, Clippy's happy. I'm going to run this again in release mode just to make sure I didn't break anything, but I'm going to commit the changes regardless because I'm not going to wait here for 4 minutes. git add source, git commit dash m 2022 day 24 part 1. All right. But let's see what part 2 is. Because maybe I don't even need to speed it up. Continue to part 2. As the expedition reaches the far side of the valley, one of the elves looks especially dismayed. He forgot his snacks at the entrance of the valley. Since you're so good at dodging blizzards, the elves humbly request that you... Oh, okay. I'm going to have to speed it up. You go back for his snacks. From his same initial conditions, how quickly can you make it from the start to the goal, then back to the start, and then back to the goal? In the above example, the first trip to the goal takes 18, trip to the back takes 23, and the trip back to the goal again takes 13, the total time of 54. Okay. Let me do it with the test input. Just to make sure that I get everything correct, and then we'll work on speeding up things. So we've already solved the going there problem here. So let's save that. First trip. So we can just say let result time is equal to this. Right? And result is now blizzard, and time is the amount of time it took, and we can just return the time for this, but what we'll do is we'll say self first trip is equal to result. That way in part 2 we only have to go through 2 more trips. Oh, but this time the goal is different. Our end state is different. We can add a Boolean here. Find start bool. Smab says, I must admit I implemented the caching the blizzard positions expecting to need them for part 2 if I ever got there. Okay. Yeah, we're going to have to cache them, aren't we? So now we're going to check the self. If self find start, then we're going to return self player pause is equal to 1 else. Else that. Right? And now what we can do, it's a little hacky, but I think it gets the job done. We can say let mutt next return trip is equal to self first trip, and then return trip dot find start is true. Let mutt back to end is equal to we want to save the time, right? Because we want to measure the time there and back again and there again. Okay. Self first trip time equals time. Return time is equal to Dijkstra search of return trip dot unwrap. All right. And then let's make sure we got the same answer. 334. Yep. 334. Okay. Good. Back to end dot find start is false. And then let final time is equal to Dijkstra search of back to end unwrap dot 1. And then we just return self first trip time plus return time plus final time. Maybe print these out while I'm doing it so I can actually see. Println return time, and then final time. And then we'll run it with the test input. What did I mess up? Oh, this doesn't exist yet. First trip time. There. Find start is false. Find start, self find start. All right. Clone. There we go. Okay, so now we're going to run, just double checking that we're doing the test input, and it should be 18, then 23, then 13. For a total of 54. Okay. All right, so what I'm going to do then is I'm going to try to make this faster by pre-caching all the blizzards. But meanwhile, this is going to run with the real input, because maybe it'll be done. Let's see whether I finish this first or whether this finishes first. So if we create the state, instead of having the blizzard like this, we'll have the state be struct state be the player's position, whether or not it's going back, the player's going back to the start, and one other piece of information is going to be the current map. Which will be an index into the blizzard. Oh, shoot, I thought I saved it with the real input. All right. Okay, try again. Right, okay, let's redo all of this, which we can't do this way. Okay, struct state. Player's position, the map number, and the find start. And then here, and we will need a blizz, RC blizzard. So what tick now is going to do, instead of doing, well, I guess we could do, all right. This goes away because now that becomes part of state. Right, we only have width, height, and map. But vec now is going to be a vec of these things. So I can just say vec new. I do need to generate the very first map. So instead of pushing it here, we'll just create a new map. Let map is equal to vec. Vec bang. Width times height as usize. And then this becomes this. I think that will get us our initial map, and then we have a blizzard. We can just say self valley map push map. right? I think that'll do this part of it. Right, it's a vector, so new just creates the width, height, and the map new. Get, we need to know which map we're looking at. So we're going to have to index it by usize. So IDX of that. The wrap still works the same. And now instead of doing this tick business on we are generating a new map. What we're going to do is, we need to figure out that we're wrapping. We have a wrapped map. So we're going to just call this generate, I guess. Maps. And where should we do that? Once we push the maps, then we can say self valley generate maps. And that'll all generate it from that initial map that we have on there. So there should only be one map when we call this. This is going to be the rest of the maps. I think what I want to do is hash them. Do I need to derive hash? Or will it automatically do that for me? I'm going to find out by doing this. Oh, because I'm not hashing on... Yeah, I'm not hashing on that. I'm hashing on... I'm no longer hashing on the blizzard. I'm hashing on an individual map. So what we're going to do is we're going to say let mut map set is equal to hash set new map set insert self map of 0. Right, self map of 0 is a vec of u8. I wish I could build this or compile it just to see what's going on, but that's not going to happen, is it? So this is the maps. So the reason I'm doing this is to check to see when we have a duplicate map and we can stop adding new maps. And then it just wraps around to the beginning again. Or we don't actually need to do that. We can just compare it to the first map and then just keep going until we hit the first map again. Yeah. And then just compare them. So get rid of that. Get rid of that. So this is going to be in a loop. It's going to say do this until right if map is equal to self map. Did I call it maps? 0 break. Wow. Ankras, hello. Ankras says you can compute the length of the cycle, by the way. Yeah, it's probably just the least common multiple of the width and the height. But I'm being dumb about it. So this doesn't return self anymore. So we don't need this part anymore. And I can't format it because I messed something else up. Oh, because I don't have RC? Right, because our new state is going to be an RC. Oops. Let me ignore that. I'm trying to see what I may have messed up without having to compile it, but I'll have to go through it. Oh. Yeah, now we can't do this. Okay, that's fair, but I just want to see what else I messed up. Okay, I get it. Right. So what we're going to do is we have to implement Dijkstra search for state instead. And the new state is going to be, instead of self-tick, we're going to have a map ID increment, right? Map index is self-clone. Yeah, we could call it self-tick, right? Because all it's going to do is say, impulse state, self, fn tick self, and return a self. It can be self of player pause, self player pause, map idx, it's self map idx +1. I guess we can just mod it once we know, and then find start. So find start. Ooh, return time is 309. Okay. And then Blizzard is going to be RC clone self blizz with lowercase. Okay. So new state is self tick. And then stay put, up, down, left, right are all correct. Those are all right. The only thing here is new state get. Right, so this is going to have to change. So new state get, we'll have to implement that. Fn get self. I gave it row call. I did. Row I64. Call, 32. I'm using 32s. Call I32. And it returns a U8. And all we're going to do is we're going to look up in the self blizz of map idx O. We don't know how many maps there are. Yeah, we can just say get map index row call. And then this has the U size, but we'll say mod self map len. How's that look? That looks good. Okay, so that's that. We'll say new state clone, we update the player position, and we push that. Okay, so that's that. The win state is still the win state. That doesn't change. Okay. What else has to change? Our Dijkstra search is no longer the self valley, but we're going to actually create a brand new state, a starting state. So let's create a new. Which returns self, which is self. Player pause is 0, 1. Map index is 0. Find start is false. And blizz, it just has to be passed in. Blizz RC Blizzard Blizz. Okay. And now part 1 becomes let state equals state new, RC new, self valley. And then result in time. Oh, right. But we're not going to have, we are going to know. We are going to know the map that we're on. Right. So this is just state. And this should return a state now and a time. First trip state is going to be the state, and we can output the time. All right, I'm going to switch back to the test input again. All right, and then part 2 is almost... Wait, first trip... Oh, we have to make changes to a state now. Right. Ooh, 934. Wow, look at how long it took. That's the right answer. How about that? All right. But now I can't check in my code because I'm in the middle of modifying it. And I'm probably breaking everything. I should have saved this off. That was dumb. Although I can recreate it pretty straightforwardly from our existing... Oh, that's why Control F wasn't working. Okay. All right, let's see what's broken. We can't do this. Oh, self map index, yeah. Right. What's next? Oh, state needs to have a derived default. Oh, and we also need partial EQ and hash because we're using that as a state. Okay. For Dijkstra. Oh, and clone. All right, what's left? Oh, we have to implement our own partial EQ because of the RC in here. Yeah, we actually don't care about that. So we just say impl partial EQ for, and then we have to implement our own hash. For state, fn EQ self other self bool. Player self player pause equals other player pause and self map idx equals other map idx and find self find start is equal to other find start. Okay, and then we also have to impl hash for state, and I forget how to do this. I think it's hasher hash t. Is it mut-t? I always forget. Yeah, it's mut. Oh, I called it h. Okay, mut h. And then we just say hash state self player pause hash state self map idx hash state find start. And then we're going to have to import all those things. Okay. And what else does it look like? Where's hasher? There it is. We could just put them together. I wish the quick action would do it. Oh, self find start. Okay, we're down to 2. Oh, we're already implementing that. And then you have to do this, impl EQ for state. And, right. Oh, I guess it's not called that. What's it called? Oh, it's just called hash. Okay. Oh, maybe this was called state. Wait a minute. What did I get wrong here? Oh, I see how it works. You have to pass in the state to the... That's awkward. Like that. Well, I always forget. I have this brain problem here. Expected reference to Blizzard found like that. Okay. Oh, right. And now we have to get the row call for the map that we're working on. Okay, so this is the let map idx is equal to 0. And we're working on map idx1, so we have to remember to increment it. Map idx. And then after each row, we just say map idx plus equals 1. And I'm just gonna, after this is done, I'm going to print it out. Println. I put it outside. I did. Okay. Map count. And it should be, 20 by 150 should be a 300. Map IDX. Yeah, I can see how this could be really, really slow. And I didn't call it maps, but I should really call it maps. Where is it? I call it map, singular. Okay. Oh, how do we know which map to draw? I guess we're going to have to pass that in, right? And now get doesn't like it. Oh, on 216? Yeah, okay. Oh, okay. And now what we're going to have to do is figure out the maps. Okay, maybe I can put that all inside get. Let's do that. So it's all in one spot. Where we implement state get. We have to be able to check to see if we're on a map. Sorry, if the map's width and height are valid for looking, right? So we can say if row is greater than or equal to 0 and row is less than self blizz height, then return that. Otherwise we're going to return that we can't go there. We'll just return wall. Blizzard wall, saying you can't go there. Right, and that simplifies this. All right, what's next? Is wind state. Oh, we need to know. Yeah, I guess we can say blizz. What's left? Do I have to do that? No. Oh, so this has Blizzard, which doesn't implement the copy trait. Do I want to make a copy of it for the first I guess so. Oops. Although maybe this it's got to be somewhere, right? The base of it has to be somewhere. I guess I could say RC Blizzard here, but then I can't modify it, right? We'll see. It doesn't like copy on this because it can't be implemented for. Oh, VECA V8. Well, we can get rid of it, right? Nope, we can't. Oh, RC new. Clone. Yeah, and now we can't bar that as mutable. That, yeah, okay. Because it's behind an RC. And we have to be able to mutate it too, right? For in the generate maps. So we can't do the RC here. But we can do it. And then generate maps, and then we can say self cell is equal to RC new self valley. Can we do that? And then this will just become a clone of the cell. Right, and now this needs to implement clone. How are we going to do this without having to copy around? All right, and the other thing is this needs to be mute self. I forgot that. Akra says, I think you should have multiple states instead of maps. I am doing multiple states, right? Every time we move. So here's the move code. We're creating brand new states. The thing is, I wanted to do is pre-generate all the maps beforehand. And then in the state code, which is where? Which I've lost. Struct state. There it is just have a reference to all of the maps rather than copying all the maps, because we need to know the maps when we're in the state. We need a reference back to the maps, but I don't want to copy all the maps. And there should be a way to do this, but I can't do a clone. Apparently I can't do a copy of a VECA V8s. Can I impl copy for Blizzard? The treat copy may not be implemented for this type. Alcra says, shouldn't it be a reference Blizzard then if it's a reference unchangeable? I was trying to use RCs to avoid that, but we can try that. Let's try it. Let's get rid of that. And then instead of saying self cell here, we just say self valley, state new, self valley. Hopefully the borrow checker won't complain. Oh, let's see, now everything gets painful, right? Oh, right. It has to be here. And now this needs, right? Impl this for state this. I'm not sure why this can't be created by default. But there you go. And then I'll need one here and here. Impl. Oops. And then this is no longer an RC. This is a reference. Oops. Tick A. Right? Can I just do that? Yeah, it needs a life. Okay, maybe I can get away without it. And can Rust infer it? Oh. Oh, we don't have a default on Blizzard? Sure we do. Oh, there's no default for ampersand Blizzard. I guess we don't need default on this. Oh, dang it, we do. If we want to save the first trip. Oh boy. Why, Rust? Why you gotta do this to me? What's a way around this? So the problem is I'm trying to save the state between the two trips so I don't have to recompute the first trip again. All we care about is the index of the map, right? We don't care about the reference to the Blizzard. We just care about these two pieces of information. So let's just save those in here instead of the first strip. Oh, we know the position. All we need is the first strip map index, which is usize. And then we can save that here. First strip map index as a resultant map index. And then we can say here, for part 2, let find home is equal to state new self valley self find home dot player pause is equal to self valley dot height -1. Oh, here comes the train. And then self valley width -2. Right, because we know that because the end state is exactly that. Okay, and then the find home dot map idx is equal to self result. No, first trip map idx. And then we'll also have to say find home. Oh, I called it return trip here. Okay, we're calling it find home. Find start is true. And then we're going to get the new state with back to end and return time. And we call this, let's call it return trip, because that was what we had before. Okay. And then this should be okay. And this should be okay. All right. Let's see if that builds. Nope. Oh, I don't need a lifetime here anymore. Which means I don't need it here anymore. Which means I don't need it there, or there, or there. It built. And I'm using the test input, cargo run. And again, here, so this is the output we're looking for here. Anka says, nice. Yeah, building is one thing. The correct output is another thing. Yeah, it's not working, right? This should have finished almost instantaneously. 8 milliseconds. Oops, I hit tab. I meant to hit Control C. All right. So self-tick, let's take a look at that. It does update the map index. I mean, we can start printing these out and seeing what they're looking like. They're going to be it's kind of annoying to look at, but we can take a look. When we do a draw, we don't have the player's position. I guess I can add that to the draw. And what I can do here, oh, yeah. We know the index because it's part of the state. So we can say for move m in moves, m dot blizz dot underscore draw m dot map idx m dot player pause println one option. And then we're going to come here and say if row call is equal to player pause, then we're going to print E, else we're going to print this. Okay, and let's take a look. Cargo run less. Smab, how was your walk? How things are going right now is I broke it. It's not even, it's generating all the maps. That's what it's doing. I should print that progress out. Let's comment this out for now. And generating the maps is taking a long time. Let's print out the map IDX as we go. Print bang. Oh, I don't know if that's going to work. Map IDX. There shouldn't be that many. It should only be like 300, right? Oh, I can't do that. Yeah, I'm not going to do it this way. I'll just do a regular print. I think that the output was just being buffered. Did I not save it? All right, so it generated those. Let's do this. Nice stroll, just under 2 minutes. Nice. Yeah, it's not stopping. It should stop at 300. Right, because map 300 should be equal to map 0. And this equality check is not working. So we're not allowed to compare vex this way or something? Or maybe the map just isn't working. Let's just generate for part 1. Oh, yeah. I mean, for the test input, I'm not going to look at 25 yet. Let's just do this and see if we can get all the cycles, and I'll print out each map as we come to it. And now we have to add the player pause. Yeah. Let's do that. Println, oh no, map dot draw. Player position is 0, 1. Okay. And what we're going to do is just add that. We're going to use the test, a tiny test input. Call it test2.text. Oops. Oh, this is just a vec of U8. Oh, am I not pushing the map? Oh, well, that would be a problem. Although this would blow up. Wouldn't it? Oh, except I'm modding it by the line. I outsmarted myself. So this should be self.maps.push map. Maybe that's the problem. Let's go back here and use the real test input. And it's only, oh yeah. So we generated all 12 maps. Perfect. And then we came up with the same answers. That's good. That's good that we came up with the same answers. Let's see if this now helps at all. I need to take out the map printing. I'll leave the map count in there. I'll leave draw alone. We don't need this, I don't think. We'll keep those in. Okay. Save that. Release. And let's see if it speeds it up at all. Our release builds are slow, aren't they? Well, that was dumb. I forgot to switch back to the real input. Let's try again. Yeah, okay, so it came up with 300 maps, which is what I was guessing it would be. But it's still very slow. Oh, it's much, much faster. Much, much faster. It was like over 4 minutes last time for part 1. Yeah, okay. This is reasonable, although it's still painful. And we get the 934. Is that the right answer? Let's go here, 934. Okay. So caching it helps, but doesn't help as much as I was hoping it would. So maybe Dijkstra is not the right answer here. Maybe A star would be better. Let me get rid of these lines. We don't need any of those. We don't need this. Yeah, okay. All right. Let's see what Clippy has. Good. All right. That was a big change, right? To cache all of those things, and I wanted to thank whoever it was who suggested not using RCs and using the I was trying to avoid the reference only because of all the lifetime business. Akras, you were the one who gave me the impetus to go with the where is it? Yeah, just adding the lifetime here so that I could have a reference to it instead of using an RC. That saved a lot of headache. Smeb says, I assume you don't have to cache more than 1,000 ticks as a result is less than that. I only cache 300 blizzards, right? Because the output, the way the output worked here, this map count says it only generated 300 maps. And so when we were walking our way through the Dijkstra steps, we only used those maps over and over again. So it took almost 14 seconds to solve part 2. All right, this is good. This is good. I'm done. I'm done thinking about this problem. If we can think of a better way to improve the speed, then maybe another time. But I'm almost done with Advent of Code 2022. So